When we have a single disturbance or event, a pulse is created which propagates away the energy from that event. A periodic disturbance or vibration would create repeating pulses or a wave. We could simply describe the back and forth motion of a vibrating object in simple harmonic motion by the equation y equals sine omega t, where y is the amplitude of the vibration, omega is the angular frequency, and t is time. The angular frequency is measured in radians per second and is related to frequency by a unit conversion. Omega equals 2 pi times the frequency, where f frequency is usually measured in hertz or oscillations per second. Because the units are in radians, we often use radian mode on our calculators. We could also express this in terms of the period of time for one oscillation t, where t is equal to 1 over the frequency, and omega is equal to 2 pi times the frequency, or 2 pi over the period. When this period of disturbances or vibration propagates outwards, it is not only a function of time, but also a function of position. Using this simulation, you can wriggle the wedge on the rope and see the resulting wave propagate outwards. You might want to set the simulation for no end so we won't have to worry about reflections. And if you set the simulation for pulse, you see the pulse traveling outwards. And if you set it for oscillation, you see oscillations traveling outwards. As you observe the waves, you will notice the position of the rope will vary with both position of the rope x and time t. We can express this with the equation y equals sine kx minus omega t, where k is what we call the wave number. There are many different parts of the wave. The high part of the wave is called the crest, and the low part of the wave is called the trough, and the displacement of the wave from its equilibrium position to the maximum point of the crest is called the amplitude A. If we are looking at a graph, which is a function of displacement versus time, then the difference in time between two crests is called the period. If we are looking at a graph, which is a function of displacement versus position, then the difference in time between two crests is called the wavelength lambda. As we mentioned earlier, the wave number k, which is actually the reciprocal of the wavelength, k is equal to 2 pi over lambda. A question is, what is moving with a wave? What is actually propagating forward? In class, we saw a ripple tank where a vibrating stick would create water waves. Another nice example we saw in class was a wave propagating on a wave machine. But what actually propagates forward? Most waves will temporarily displace something as they travel. In the case of a water wave, the answer is self-explanatory. Electromagnetic waves electromagnetic fields propagate. Gravitational waves interact with mass, and sound waves will compress the medium as they travel along. We shouldn't assume that this disturbance has to be perpendicular to the direction of propagation. When it is perpendicular, producing crests and troughs, we call it a transverse wave. However, if the disturbance is parallel to the direction of propagation, then we call it a longitudinal wave. In this case, instead of crests and troughs, we have compressions and refractions, as you can see in the video on the blog, where we have a slinky which gets compressed and stretched out. A refraction is another word for stretching out.